are covering a very important topic. Slope and rate of change. Now you're going to see this a lot over the next 4 years in math. This topic shows up a lot in the future. Learn it now and make good grades from here on out. Are you with me? All right, let's talk about what slope is. The slope is the steepness of a line. So let's think about this for a minute. Think about snow skiing. Are you with me? You recognize steepness of a line real quick when you get on the top of that slope. When you get on the top of a slope that looks like this, are you very scared? No. No. Man, you're going to ski nice and slow down that slope. Are you with me? That one didn't scare me at all. That one scares me. Why? That sucker's steep. I'm going to go fast. I'm probably going to hit a tree and y'all are coming to my funeral. Are you with me? I don't like skiing on those slopes. I like skiing on slopes like this. Are you with me? Or somewhere in between. Does that make sense? I'm too old to ski that crap. Are you with me? Hospital, death, funeral. Good time over here. Pretty good time over here. So, the steepness of a line is what we call the slope. And that makes sense when you go skiing. Dude, that's a nice slope. You say it on the ski run. It's a slope. Okay. Now, we have about 3 different ways to find slope. We're going to cover all of that. Let's start with the table. So let's say they give us information in the form of a table. Let's make it easy, 10, 13, 16, 19. To find the slope from a table, you do this. We call it delta y over delta x. Now that little triangle is the Greek symbol for delta. What it really means is the change in y over the change in x. So circle that and put it right next to that. Delta y means how much of the y is changing. Delta x means how much of the x is changing. Well, we can look at the table and figure that out pretty quickly. How much are the y's changing from 10 to 13, Tucker?
It's going up by 3.
Going up 3. Do y'all agree with Tucker?
Yes.
What about the next one?
3.
What about the next one?
3.
All right, so do y'all agree that the change in y is going to be 3? Hello?
Yes.
Sweet. Let's find the change in x now. How much of the x is going up? Here? Here? So what would y'all say the change in x is?
1.
There is your slope for this first example. We like for the slope to be a fraction. We want to know what's on top. This y's are changing by 3, the x's are changing by 1, therefore the slope is 3 over 1. Questions? All right, let's look at another one. Let's find the slope of this set of data the same exact way. All right, how much are my y's changing?
7.
Here?
7.
Here.
7.
So let's go ahead and put 7 for the change in y. How much are my x's changing?
Negative 3.
They're going down 3. You need to put negative 3. Now, let's say that you're not sure how to figure out if it's going up or down. Everybody pick up your calculator. The calculator is going to be a nice help on this. Watch. Type in the second number first, negative 8. Everybody use the little negative button at the bottom, not the minus key. And then subtract, hit minus. The top number, hit -5. Hit enter, and the calculator will tell you how much they change. But you've got to type in the second number first, minus the first. Here's what you need to type in to the calculator. -8 minus -5, and the calculator should give you that number on your screen. Are you with me? All right, let's keep going. How much are these changing?
-3.
-3. How about here?
-3.
So what is the change in x?
-3.
There is my correct slope for this set of data. Questions? All right, let's do one more. Sometimes you might have to reduce the slope. I've got a nice trick for that one too. Ooh, 48. All right, let's find the slope of this bad boy. How much of the x's, I'm sorry, the y is changing?
6.
8. How about here? 8. How about here? 8. Y'all agree that the change in y is 8?
Yes.
Let's find the change in x. How much are they changing?
16.
Here?
16.
Here.
16.
And that reduces, what does 8 over 16 reduce to? What? 1/2. Now, pick up your calculator. Here's a nice trick. Have I showed y'all how to reduce yet on the calculator? Everybody type in 8 divided by 16. Do not hit enter. Just type in 8 divided by 16. Now there's a little button on the left-hand side that says math. Everybody hit that button one time. And that'll bring up a list of things. Do you see the very number 1? It says reduce fraction. Do y'all see that? It's got a little arrow frac. Hit enter, and hit enter one more time, and boom, the answer to your reduced fraction shows up on your nice calculator screen. Any questions?
Is there any way that the x could change numbers?
We're going to talk about it. Good question. So hold that thought. I will answer that one momento. All right. Any questions on how to find a table? Changing y over changing x.
Here's smart cuts real quick.
All right. Thank you. My wife doesn't always think so, but you keep telling her that, Crosby. I like the way you think, son. All right. Now let's look at a set of ordered pairs. If they give us some ordered pairs, like 3, 7, 5, 12, and ask us to find the slope or the rate of change, by the way, these two words mean the exact same thing. Okay? Slope and rate of change are the same exact thing. All right, we've got a formula for ordered pairs. Here it is. y2 minus y1 over x2 minus x1. So write that formula down. That's the formula we're going to use anytime they give us a set of ordered pairs. We need to plug in a number for each of these. We're going to plug in a number for y2, a number for y1, a number for that, and a number for that. Good. What's the first number in an ordered pair?
3.
Not 3. That's the x. What's the second number in an ordered pair?
1.
What's the first number again?
X.
What's this? Okay, so isn't this the first pair they give me?
Yes.
So these will both be x1, y1. Isn't this the second number of ordered pairs? This will be x number 2 and y number 2. And now we're going to plug in the numbers over there where they go. So what number do I need to plug in for y2?
12.
I haven't picked anybody. Yolette. What number is y2 over there?
12.
12. We're going to subtract y1. Jinx,
7.
y'all agree with Jinx at 7?
Yes.
I do too. So we've done Y2, we've done Y1. We are not using those numbers anymore. Some kids use the same number twice. Don't do that. All right, what's X2, Xavier?
5.
5. And we're going to subtract X1. Jake, what's X1?
3.
3. Any questions so far? So we plugged in Y2 minus Y1. Then we plugged in X2 minus X1. Now let's do some math. What's 12 minus 7?
5.
What's 5 minus 3?
2.
There is your correct slope for this example. 5 over 2 would be the correct slope. Questions? All right, now this formula is nice and easy until we start putting negatives in there. That's when some kids start, okay. So let's put some negatives in. That formula remains the same. Let's do negative 7, 6, and 5, negative 12. Okay, we're going to label them the exact same way. What are these going to be? X1, Y1. What are these going to be?
X2.
X2, Y2. Let's go. All right, what number is Y2? I'm picking, let's go with Angel. Negative 12, I agree with Angel. We're going to subtract Y1. Let's go with Crosby. What's Y1?
6.
Good. Negative 12 minus 6 is on the top. All right, let's go to the bottom. What's X2? Madison. 5. Minus, what's X1? Let's go with Joseph. Negative 7. Okay, questions so far? All I've done is plug these 4 numbers into that formula over there. Now we're about to do a little math. Here's where I would highly recommend start using your calculator. Type in negative 12 minus 6. What is the correct answer? Negative 18. Be careful down here. Do y'all see the 2 negatives? Remember when we did integers? What do 2 negatives back to back make? You got to change that to a plus. What's 5 plus 7? What? 12. All right, type that in. Hit math, enter, and reduce it. Because it does reduce. So type in negative 18 divided by 12. Don't hit enter, hit math, enter. Jinx, what do you got?
Negative 2, or
Read what's on the screen, my man.
negative 3 over 2.
Thank you. Negative 3 over 2 is the reduced slope. Questions? All right. And lastly, let's look at graphs. That's our third and final way to find the slope. All right, let's say they give us a graph. And let's make it fairly easy. Let's say the line, let's start over. Let's say the line goes, that's better, through these 2 points. We need to find the slope of this graph. All right, anytime they give you a graph, you're going to find 2 things. You're going to find what we call the rise and what we call the run. Write it down, rise and run. I'll give you a second to catch up. All right, do y'all see my 2 points on the graph? We are going to start at the lower point. And which direction does rise go?
Up.
Straight up. If I tell you to rise out of your desk, you're all gonna get this way. Are you with me? So we're gonna go straight up. And what direction do we run?
Up.
This way. Are you with me? Run goes that direction. Are you with me? So watch. I'm gonna start right here at this point. I'm gonna go straight up until I get even with the next point. So I'm gonna go up 1, 2, how many did I rise? So I'm gonna label it. The rise is 3. Now let's count the run. So we went up 1, 2, 3. Now we gotta go straight over until we hit the point.
1, 2, 3, 4, 5.
Okay, so we went a run of 5. So there is my correct slope for this line. The rise is 3, the run is 5. It has a slope of 3/5. Now we need to talk. If the line goes in this direction, the slope will always be positive. And I'll tell you how to read it in just a second. If the slope or the line goes in this direction, the slope is always going to be a negative slope. And we read a line just like we read a book. When we're reading a book, don't we go left to right? So if I put my finger on the left side of this graph, which direction is it going? Is it going up or is it going down? That's going up. Any graph that goes up has to be a positive. Any graph that goes down has to be a negative. We put our finger on the left side of the graph every time. Are you with me? We don't put our finger on the right side, because then we would get them all backwards. If I look at it from the right, that looks like it's going down. But we don't read it from the right. We read it from the left to right. Are we clear? All right, let's do another one. We'll make this one easy. Let's put a point here, and let's put another point here. Let's find the slope of this line. Which point is lower? The left or the right? The left is lower, the right's lower. So I always start at the bottom point of the graph. So I'm going to go straight up. How many do I need to go up? 1. So the rise would be 1. I'll put a little 1 there. Now we're going to go straight over. Count with me.
1, 2, 3,
4.
We're there. We've reached our destination. What's the run? 4. And there's only one thing we need to add. What direction is this line going? Down. It's automatically a negative 1/4. Questions? Okay, now we covered a lot of information today. We got graphs, tables, and ordered pairs. We've got a way to find the slope for each one. Question?
Will the bottom ever be negative?
No, the whole slope is negative. So the slope, Rylan, will either be going down or the slope will be going up. Does that make sense? Now there is a way to get both numbers negative. When we're like doing the y2 minus y1, well that will reduce to a positive because the negative on top and the negative on bottom will make a positive. Good question. Any others? All right. Oh, I forgot one thing. We're almost done. Let's go back to tables. Let's find the slope real quick. This is an easy one. How much are the y's changing? 2. How about here? 4. How about here? 2. How about here?
1.
Here?
1.
Here.
1.
Okay. For you to be able to find the slopes have to be the same all the way through the graph. Are you with me? Is 2/1 the same as 4/1?
Yeah. No.
No. 2 over 1 and 4 over 1 are different. This problem doesn't have a slope. It is not a straight line. Are you with me? The slope has to be the same number every time, or we cannot find the slope. So you would say, there is no slope on this one. It is not a straight line. Question.